Welcome to Lecture 12. We are studying 5.3 and 5.4 today. And these formulas right here that you see in front of you are the formulas that we will be using today for the lecture. So the first thing you need to do is to get them out in front of you yourself. So if you go to the very back of your textbook, you're going to find the sum and difference identities for 5.3 and 5.4 listed in the very back of your book in a single box. So let me show you right here. So in the very back of your textbook, very back, here we go, there's a box that says 5.3 and 5.4 sum and difference identities, and they are going to absolutely just match what you see right here. Okay, so the first thing we have to learn is how to use the cosine ones, that's 5.3, and then we learn to use the sine and the tangent ones in 5.4, but basically it's a united, they really could have put it all in one unit together, one lesson together, because we're just doing the same thing over and over again. So pretty simple and straightforward. I'll be working through 12 problems today. Okay, so the first problem we're going to be working through is from 5.3, page 218. I didn't tell you the problem number. This is number 12. Now, the directions for number 12 say, find the exact value of each expression. Do not use a calculator, aka, or in other words, i.e., there we go. In other words, use the unit circle. So what we're going to be doing is we're going to be trying to find two angles that either add up to or differ by 105. And those two angles need to be from the unit circle. Now, it doesn't matter whether you choose add up to or differ by. It's a complete arbitrary choice. Since number 12 gives us a hint that 105 is the sum of 60 and 45, we'll just work with what the hint that's given to us is. So the first thing we want to do is we want to rewrite this expression as cosine of 60 plus 45. So I've done nothing more than split 105 into 60 plus 45. Very simple and basic. So what was my motivation for doing that? My motivation is this. 105 degrees is not on the unit circle. However, 60 and 45 are on the unit circle. So I'll be able to figure out the cosine of 105 using trig values as 60 and 45. Now, it's really important to note that this does not equal the cosine of 60 plus the cosine of 45. That's not how it works. Okay? Remember, I just had shown you all of the formulas. These are the formulas right here. If you have the cosine of two angles added together, then this is the formula we use. I call this cos minus sine. And since multiplication is commutative, it really doesn't matter which of these two cos's come first and which of these sines come first. Okay, so we're going to be using cosine A, cosine B minus sine A, sine B. So back to here, we are going to replace every occurrence of A in the formula with our first angle, 60, and every occurrence of B in the formula with our second angle, 45. Okay? So that is going to be cosine of 60, cosine of 45. Now we have to remember, this is a plus. So was this a plus or was this a minus? Let's check. With the cosine sum, there's actually a subtraction sign in the middle. So what we're observing here is that when we're having a cosine sum, you have subtraction, and a cosine difference, then you have addition. So this middle sign here is the opposite of what you see there. So keep that in mind. So now we have minus sine 60, sine 45. And sometimes I may write those out of order, these two, flip them around. It doesn't matter. Multiplication is commutative. What matters is that you have your cosines first, then subtraction, then your sines. Now we're going to go through and do substitutions from the unit circle. So my next setup is just going to be to put a bunch of parentheses up. And I'm going to replace cosine of 60 with its value, cosine of 45 with its value, sine of 60 with its value, and sine of 45 with its value, all from the unit circle. Okay, so at 60 degrees, I use my arms to figure out the values. Here's my unit circle right here. Here's my first quadrant right here. 60 degrees is right here, so the cosine is going to be 1/2. 45 degrees is right here, so the cosine is root 2 over 2. 60 is right here. The sine value there is root 3 over 2. And sine of 45 is root 2 over 2. So after you do that replacement step, now we're going to just do some simple multiplication. To combine these, 1 times root 2 is root 2. 2 times 2 is 4. Root 3 times root 2 is root 6. 2 times 2 is 4. We have a common denominator here, so we can combine these. Root 2 minus root 6 does not simplify any further. So that is the final answer. Notice that this is an exact value. When you type something like this into My Open Math, make sure you have parentheses before you divide by 4. Okay, so that was question number 12. Next up is question number 16. Okay, so for question number 16, we likewise need to find the exact value. Of course, negative 7 pi over 12 is not one of the values on the unit circle. So let's think about the values on the unit circle in terms of twelfths, okay? We have pi, which is going to be a 12 pi over 12. We have pi halves, which is 6 pi over 12. What else do we have on the unit circle besides pi and pi halves? We have pi thirds, right? And that is 4 pi over 12. We have pi fourths, which is 3 pi over 12. And then lastly, we have pi sixths, which is 2 pi over 12. So we have the pi 6 values, the pi fourths, the pi thirds, the pi halves, and the pi's, and of course we have 0. And so by writing all of these with the denominator of 12, it's going to make it a little easier for us to find two that we can combine together. We also have other values like 3 pi fourths, right? 3 pi fourths would be what? 9 pi over 12, and we have 2 pi thirds, and we have all of those other values. So we have a lot of different values that we could put up here, and these really don't have to be listed. These are just things that should be floating through your brain. If you don't think in terms of fractions very easily, you may need to list them out. Now, the most natural choice would have been to combine a negative 4 pi 12s and a negative 3 pi 12s, and 4 pi and 3 pi together make 7 pi, so we could have a negative 7 pi 12s. The problem with that is that that is a cosine sum, and I just already showed you a cosine sum, so I want to show you a cosine difference. So instead of putting these two together, I'm going to do 9 minus 2, right? So 9 pi minus 2 pi is 7 pi, but I want a negative, so to get the negative of that, I'm going to flip it around, and I have 2 pi minus 9 pi. So let me rewrite this now. For some people, this is the hardest step of the process. You have to think of two values on the unit circle you can add together, or you can subtract one from the other, but they're values that are actually on the unit circle that add up to or differ by your target. And if you're really good with fractions and numbers go easily in your head, that was a fast step. If you're not good with them, I would just recommend you list things out until you can find a combination that works. It's a little like factoring. Okay, so except with factoring, you only have usually one choice that's going to work, whereas here we have a whole lot of different choices that would work. Now, the next line, I'm going to make this a little easier for us to visualize. I will rewrite this as cosine of pi 6 minus 3 pi fourths, right? So what I just did is I reduced 2 pi 12ths to pi sixths, and I reduced 9 pi 12ths to 3 pi fourths. Now, you can see these values a little more easily on the unit circle. So I'll be using those. Now let's refresh our memories as to the cosine difference formula. We have cosine A minus B is a cos plus sine. So we're going to be doing the opposite of what we did last time. So first, we do cosine of pi 6 times cosine of 3 pi fourths, and then we're going to have a plus sign because this sign will be, these will be opposite signs there. And then we have sine pi 6 sine 3 pi fourths. I see that the glare is there, so that's not good. Okay, but we're going to be moving down to the next line here where we're going to be condensing everything. We are going to replace each of these occurrences, cosine of pi 6 with its value from the unit circle. Okay, so pi 6 is right here, so the value is root 3 over 2. Cosine of 3 pi fourths is way over here, so that cosine value is negative root 2 over 2. Sine of pi 6 is 1/2. Sine of 3 pi fourths, that's way over there, so that's root 2 over 2. This really made a difference for me memorizing the unit circle using my arms, because the height represents the y value, and then how far over you go with your arm represents the x value. And so I can figure out my x value and y value just by like feeling it in space. Maybe that works for you, maybe it doesn't. All right, it's kind of like memorizing where things are in your kitchen at night when it's dark and you can just go and find the cookies. Root 3 times negative root 2 is negative root 6. Then we have plus root 2 over 4. And so my final answer is negative root 6 plus root 2 over 4. Alternatively, you could write that, make sure the negative is in the numerator. We do not want the negative to be out in front. I almost wrote it in an ambiguous way where the fraction bar wasn't long enough. Make sure that the negative is clearly in the numerator. You can alternatively write this as root 2 minus root 6 over 4. Now, if you ever want to check your answer, you can check it on the calculator by getting decimal approximations, right? So, if you get your calculator and you put it in radian mode, okay, and then I'm going to take my calculator and I'm going to type cosine of negative 7 pi divided by 12. And when I do that, I end up with this decimal approximation of negative 0.2588, blah, blah, blah. Now what I want to do is I want to compare this decimal approximation to this fraction right here. So next I'm going to type parentheses root 2 minus root 6, end parentheses, divide by 4. And you can see now what has happened is my fraction that I have, root 2 minus root 6 all over 4, and notice my use of parentheses, gives me the exact same decimal approximation as cosine of negative 7 pi over 12. So there's no reason for you to not know that you have the incorrect answer. Of course, on homework, you can know you have the incorrect answer by looking in the back of the book. But on quizzes and tests, this is a really useful thing so that you can know right there that you got your answer right. Okay, next we are going to be doing number 18. Okay, so here's number 18. Now we need to find the exact value. 7 pi ninths, 2 pi ninths, those values are not on the unit circle. But in glancing at this expression, it should remind us of something. Cos, minus sine, sine. Which of those formulas is that? Cos, minus sine, sine. Oh, that's cosine of A plus B. So all I need to do is rewrite this as the cosine of A plus B. What's A? 7 pi ninths. What's B? 2 pi ninths. What is that? The cosine of 9 pi ninths. In other words, pi. Cosine of pi is -1. So that's your exact value, and you're done. So this would be the work that you would show for a problem like that. So remember that you want to show your work in your homework the way I tell you to. And also, on the test, it's really important that you show your work as I demonstrate it if you want full credit, all right? So now the next problem is number 54. Here's number 54. When I first copied it down, I copied it down as a blend between two different problems. So always make sure that when you copy your work, you double check that you copied it from the correct problem. Okay, this is a trickier problem than what we had before, but it doesn't need to be tricky if you draw diagrams and you label them correctly. So what we're trying to do is find the cosine of s plus t and the cosine of s minus t. So simple enough. Let me come down here and write those out. Okay, the cosine of s plus t is going to be cos of s times the cos of t minus, these parentheses are not necessary, but it bothered me to have a cos and an s right next to each other, so that's why I did that. Okay, cos s cos t minus sine s sine t. Okay, so now I just need to replace cos s with its value, cos t with its value, sine s and sine t with those values. Okay, so I have sine of s. Sine of s is 2/3. And I have the sine of t. That's -1/3. But I am missing cos s and cos t, so I need to find them. I'm going to find them by drawing quadrants, and in those quadrants drawing triangles and labeling the sides of the triangles. So which quadrants are we going to be drawing? We're going to be drawing one quadrant 2 and one quadrant 4. So here is my quadrant 2, and here is my quadrant 4. Okay, so in my quadrant 2, I am going to find the angle S. So here is S. S is in quadrant 2. And in quadrant in quadrant 4, I'm going to find T. And the reason I made S closer to the y-axis is because I can see that the sine value of 2/3 is going to be closer to 1 than 0. And the reason that I made T so close to the x-axis is because the value is just -1/3. Now from these angles, I'm going to drop a perpendicular to the x-axis. And the result, notice the use of the right angles, the result are the reference triangles for S and T. Now using the reference triangles, I can figure out what these missing values are. So I just need to label the sides with what I know. Now for S, the sine ratio is 2/3. So you can use any ratio of 2/3. You can use 4/6. You can use any of them. But the obvious, simplest choice would just be to use 2/3. So we're going to do that. Sine is opposite over hypotenuse, right? So the missing side you can find using Pythagorean theorem. You do not need to show the work of showing the Pythagorean theorem. We did that in the previous unit. So instead, you can just do this in your head. You've got 9 minus 4 is 5, so this is the square root of 5. The length of this side is the square root of 5. But I'm going to go ahead and label it with negative so that I can remember I'm going to the left here, right? I'm in quadrant 2, so I need to have a cosine value that is negative. So my cosine of S is then negative root 5 over 3. And again, I got this value using the Pythagorean theorem. Now we come over to t. I'm going to go ahead and label this side negative 1 because I'm going down. The hypotenuse will always be a positive number, so make sure your hypotenuse is always positive. And then moving from here to here, the x value is going to be found by doing 9 minus 1, right? So square root of 8? Yes. All right, square root of 8 is the same thing as 2 root 2. Use Pythagorean theorem to find your unknown side. Simplify the radical as much as possible. I simplified the square root of 8 into 2 root 2, and then label it appropriately, positive or negative, based off the quadrant it's in. Now, the cosine of t is then 2 root 2 over 3. And we can combine these fractions now. Here we have a negative 2 root 10 over 9 minus minus, right? So that would be plus 2 over 9. We can combine that to be 2 minus 2 root 10 over 9. Moment of truth. Let me check that I got that right. They wrote it the opposite way, but it's fine. Okay. So that is the cosine of s plus t. They wrote it with the negative 2 root 10 plus 2 first. Same thing though, of course. That's the cosine of s plus t. Now we need the cosine of s minus t. The cosine of s minus t is going to be the exact same process as this, except we're going to switch a few signs, right? So allow me to just do my cheat work here of the luxury of doing math on a whiteboard is you can make erasing really easy. Okay, in your work, of course, you need to show all your work, but here I'm going to do some magic. S minus t, then the formula turns here into a plus, so this is a plus, and then this would then be a minus, and so I would have a minus 2 root 10 over 9. Cosine sum and cosine difference formulas are really similar. The only thing that's different about them is that middle sign. Okay, so that's all of 5.3. So next we're going to move on to 5.4. Okay, so frequently I do the even problems that correspond to odd problems I assign. Hopefully you've already noticed that, and then you can work through your homework as I go through the lecture if you want. That way you can pause it, and every time I do a problem that resembles one of the problems that I assign, you can work through it that way. That's one idea. Alternatively, of course, you could watch the whole lecture all at once, and hopefully you digest a good bit of it. Sine of 255 is not on the unit circle, because 255 is not on the unit circle. But 255 is the sum or the difference of two values that are on the unit circle. And it's up to us to choose if we want to use sum or sign difference. A natural, easy choice would be just to make this equal to the sine of 210 plus 45, since 210 and 45 add up to 255, and both 210 and 45 are on the unit circle. So then what we do is we flip over to our formula, and we see that the sine sum formula is sine A cos B plus cos A sine B. So notice that with the sine sum and difference formulas, the addition and subtraction sign here, inside matches the one in the formula. This is the opposite of what's happening with cosine. So we have sine A cos B, cos A sine B. So that means I want to write this as the sine of 210 cosine of 45, and then plus cosine of 210 sine of 45. Now, if you swap those, it doesn't matter. Multiplication is commutative. So now what I do is I substitute each of these with their respective values from the unit circle. So 210 degrees, sine value is negative 1/2. Cosine 45 is root 2 over 2. Cosine of 210 is negative root 3 over 2. And sine of 45 is root 2 over 2. So this is going to simplify into negative root 2 minus root 6 all over 4, which you can check directly with calculator approximations. So it's the same as we did with the cosine sum, just different formula, but the exact same concept. Okay, so next we'll look at number 16. Now we're going to look at the tangent formula. I'll go ahead and use tangent sum since that's going to be the most natural, easy one to use here. 5 is 3 plus 2, so this tangent of 5 pi 12ths is the same as 3 pi 12ths plus 2 pi 12ths. Of course, I could have also written it as 2 pi 12ths plus 3 pi 12ths. That doesn't matter. Okay, so now I'm going to reduce to pi over 4 and pi over 6, which are the values that we actually see written on the unit circle. That's just reducing those values to these values. So it's helpful to learn to think of all the values on the unit circle in terms of the denominator 12, equivalent fractions for each of those. The tangent sum formula is tan A plus B. Here in the numerator, tan A plus tan B. This sign right here is going to match this sign. And then the denominator is 1 minus, so this is the opposite sign, tan A, tan B. There's tan A plus tan B, and then 1 minus tan A, tan B. This will give us a complex fraction, but we can do complex fractions, right? You got through college algebra. So next we're going to replace each occurrence of a trig function with its value from the unit circle. Okay, tangent of pi fourths is easy, that's 1. Tangent of pi 6, okay, so the sine value is 1/2, and the cosine value is root 3 over 2. So that becomes 1 over root 3, which is root 3 over 3. So now we need to do something to simplify this complex fraction. What I like to do with complex fractions is clear the little denominators. And so I multiply the numerator, the big numerator, and the big denominator by the LCD of all the little denominators. We only have one little denominator number, and that's 3. So I'm going to multiply by 3 over 3. And that is going to give me 3 plus root 3 all over 3 minus root 3. Yes? Yes. Okay. Next, I have to rationalize the denominator. And to rationalize the denominator, we use the conjugate of the denominator, right? So we're going to multiply this fraction by 3 plus root 3 over 3 plus root 3, because that gives the those conjugate pairs will cause us to have a difference of squares in the denominator, and that would rationalize it. So we have lots of good review from college algebra here. The numerator, when you square a binomial, you get a trinomial, right? So you end up with 9 plus 6 root 3 plus 3. There's your trinomial that results from squaring the numerator. And then for the denominator, you have your difference of squares, so you end up with 9 minus 3. And of course, we can simplify all this. This numerator becomes 12 plus 6 root 3. And the denominator is 6. And then that simplifies further. I'm running out of board space. Okay, well, the good thing is we don't have a fraction anymore, right? When this simplifies further, we end up with just 2 plus root 3, which is remarkably simplified. So it makes me wonder, am I even doing this correctly? Well, this is where I get out my calculator. And you will be switching back and forth between radians and degrees to make sure you are in the correct mode. I'm still in radians from earlier when I checked. Okay, tangent of 5 pi over 12 gives me 3.73, etc. And then 2 plus root 3 is 3.73, etc. And yay, we did it correctly. So quite complicated in its algebra, but it's really not anything too new, okay? The idea of adding fractions together, this might trip you up a little bit, but ultimately that's a review of elementary school addition. Then we're using a new formula, but it's just a formula. You're just making substitutions into a formula. We're reviewing the unit circle values, which the better you get at the unit circle, the faster this will get. And then we're reviewing some algebra skills of how do we clear a complex fraction, or how do we simplify a complex fraction, and how do we rationalize denominators that have a binomial irrational number using the conjugate. So lots of good review of other concepts. Next problem. Okay, here's 28 and 30. I decided to put them up both at the same time. We can do them at the same time, because ultimately what we're going to be doing is just matching what we see here in each expression to its respective formula, right? So this is sine cos minus cos sine. So which formula is that? We have sine cos minus cos sine. Okay, so that's sine of A minus B. So we can do that. Sine of A minus B. All right, so now, of course, they need a common denominator. 5 pi over 9 is the same as 10 pi over 18. 10 pi minus 1 pi is 9 pi. So this is sine of 9 pi over 18, which is, of course, the sine of pi halves, which is 1. Yay. Okay, next we're going to look at number 30. Number 30 is a tangent formula. Tan minus tan is going to give us the other formula that we hadn't looked at yet. Tan A minus B is tan A minus tan B. This is going to match exactly what we have on the board, so we want to use tan of A minus B. Minus a negative 55 is going to be the same thing as the tan of 135, and 135 is going to be, we're looking at the sine of 135 over the cosine of 135. The sine value at 135 is root 2 over 2. The cosine value is negative root 2 over 2. So that gives you a value of negative 1. You do not need to show all this intermediate work. You can go straight from here to here. There we go. You can go straight from here to here. I was just reviewing the process again of how we get these values of tangent from the unit circle. So there's 28 and 30. We are 2/3 of the way through the lecture. Good. Next, we get to do number 42. Okay, number 42. We're going to be using a sign difference formula. So the sign difference formula is right here. Sine A minus B, that's going to give us sine cos minus cos sine. So here we have sine cos minus cos sine. After enough use, you might memorize these. Of course, you get your notes, you get the back of the book, all of that on your quizzes and tests, so that's nice. The sine of 3 pi fourths is root 2 over 2. Cosine x just stays cosine x. The cosine of 3 pi fourths is negative root 2 over 2. So we can simplify this into, you could write this a variety of ways. You could write this as root 2 over 2 cosine x plus sine x. I'm interested in how the book is writing their answer. Okay. That's another way of writing it. They wrote it like this. Root 2 times the cosine of x plus the sine of x all over 2. Of course, these are equivalent. 2 different ways of writing it. Either way is fine. Ultimately, we just simplified as much as possible, and that's the goal of the problem, just to get everything in terms of cosine x and sine x. Okay, so the next problem then is number 54. Okay, here's number 54. Take a moment to digest that. Triangles, right? So we have S in quadrant 2, T in quadrant 1. So we want to set up quadrants, set up triangles, label all the sides of the triangles. You might want to just do that first before you even get started on trying to figure out A, B, and C. So we'll go ahead and draw quadrants here. We have quadrant 2, quadrant 1. My S value is in quadrant 2. There is S. S is pretty close over here to the negative x-axis based off the ratio here being really close to negative 1. And then over here, T is in quadrant 1, and the sign value is close to positive 1, so I'll have T be way up here. Ultimately, as long as your labels are correct, your triangle does not need to be drawn to scale, right? So don't stress too much about exactly the angle of S and T. Just make sure you end up in the correct quadrant. Next, I drop perpendiculars to the x-axis to form reference triangles. And then I label the sides. So the hypotenuse is always positive. Here we have negative 15 for the x value. And then over here we have 4 over 5. This is an easy 3, 4, 5 triangle. And I'm pretty sure 15 and 17 are a part of a Pythagorean triple too, but let me just check so I don't do something foolish. Yes, 8, 15, 17 is another Pythagorean triple. So that means that the missing side here is 8. Okay, so next I do part A using the formulas. So part A, I need the sine of S plus T. So this is going to give me sine S cos t plus sine t cos s. Now, the formula may actually be cos s sine t. I forgot, but it doesn't matter. Okay, so now I'm going to replace each of these values. Yay for the commutative property of multiplication and addition. Sine of s is 8 over 17. Cosine of t is 3 over 5. Sine of t is 4 over 5. And the cosine of s is negative 15 over 17. Denominator is 85, right? So you have 24 plus a negative 60. That would be a negative 36 over 85. And that is fully reduced. Okay, next, the tangent of s plus t. So much nicer when you don't have irrational numbers, right? Tangent of s plus tangent of t over 1 minus tan s times tan t. It's worth copying this. Now, you may say, why am I copying the formula? I'm not actually copying the formula. I'm copying the formula applied to specific values of s and t. Because the formula is going to usually be a, b, alpha, beta, whatever you're looking at, x, y. I'm showing the formula being used specifically for s and t. So I'm not just recopying the formula. I'm copying the application of the formula to this problem. So this is an important step to include in your work. Okay, so now the tangent of s and the tangent of t. What are those values? The tangent of s opposite over adjacent is negative 8 over 15. The tangent of t opposite over adjacent is 4 over 3. And it looks like the least common multiple of 15 and 3, or rather, it doesn't just look like, it's true. The least common multiple of 15 and 3 is 15. But over here I have another value. I have 45. So I have 15, 3, and 45. So really the LCD for all of them is 45. So I multiply by 45 over 45. And I'm, of course, in a corner again. You'd think I would learn. Okay. 45 and 15 will cancel, giving me 3 times negative 8 is negative 24. 45 and 3 cancel to give me 15 times 4 is 60. Here I end up with 45 plus negative is a plus. 15 and 3 cancel entirely with 45, leaving me with 32. So this is 36 over 77. These are not problems that you can just rely on your calculator for. Now let's notice this. We have a sign value that is negative, right? Where do we have sign values that are negative? Only in the third and the fourth quadrant. Then we have a tangent value that's positive. Where do we have tangent values that are positive? Only in the first and third quadrant, which means that this s plus t, the quadrant of s plus t, would have to be in quadrant 3. So the answer to part C is quadrant 3. And the way you come to that conclusion, again, is by looking at the sign of the resulting values from part A and part B. Okay, so you do part C after you do A and B. It does not require work. You need to think through which quadrant could S and T possibly be in based off this resulting sine and tangent values. Okay, 2 more problems. The last 2 problems are going to be proofs. We are not done with proofs. We spent time in 5.2 considerably to prepare us for a continuation of proofs. You'll notice that the good thing about this course is it builds and it keeps building on previous concepts. Now, that's a problem if you don't get a previous concept, but the good thing about that is in terms of comprehensive mastery for the whole course, you'll get to continuously almost review previous concepts. There are some concepts that kind of branch out and are not so dependent on other concepts, but as we move forward to the final exam, we really want to go for comprehensive mastery. Try to review as much as possible of previous content, and that's a good thing. Okay, so for our last 2 problems, the next one is going to be number 62. So here's number 62. I'm going to prove that the left is equal to the right. Verify the identity, it says. So that means I'm going to start by drawing my line under the equal sign. And the left-hand side, I just get to apply the formulas for sine sum and sine difference. I'm going to need to make sure I leave plenty of room, of course. So here's the sine sum. Sine sum is sine x cos y plus cos x sine y. And then I need to, I did not leave enough room. I have to get smaller in my writing, or I have to be creative in how I move my red line over. Whee! There we go. Now I have more space. Sine of x minus y is sine x cos y minus cos x sine y. So all I did was apply the sine sum and sine difference formulas to these particular values, x and y. Now the good thing is I have just found 2 additive inverses, right? The cosine of x sine y, that's a positive one, and negative cosine x sine y, that's negative. And oh look, I am left with just 1 sine x cos y plus 1 sine x cos y, and that is 2 sine x cos y. So that was not too hard, was it? Yay, that's exciting. Okay, the next one is number 68. Okay, so here is number 68. Let's start by applying the sine sum and cos difference formulas. So the sine sum formula is sine x cos y plus cos x sine y. And the cos difference formula is cos x cos y plus sine x sine y. Okay, and then I do that and I have no clue what to do next. That's not true. I have an idea. I just don't know exactly if it's going to work. Let's try it. Okay, so over here, I'm looking at cotangent of x, cotangent y, and I'm thinking, I could rewrite that in terms of 1 over tan, or I could rewrite those in terms of sine and cosine. Now, which one would make more sense? If I write cotangent as 1 over tan, I could certainly end up with a nice complex fraction that could be simplified further, but I really probably won't go directly to anything that relates to cosine and sine. So it makes more sense to go ahead and replace every occurrence of cotangent with cosine over sine. So here we have cosine x over sine y plus, oops, no, not true, cosine x over sine x plus cosine y over sine y, and then 1 plus cos x over sine x times cos y over sine y. Now, this is a nice big complex fraction, and the denominators I have are sine x, sine y, and sine x, sine y. So obviously the LCD is sine x, sine y. I should be careful not to use the word obvious. I had a math teacher once who had a sign on the wall that said, "Obvious is the most dangerous word in mathematics." It's true. It's easy to leap to conclusions, and they may actually seem correct, but are not correct. So we should not take anything lightly. Obvious is a dangerous word. Sine x, sine y over sine x, sine y. Now we can clear this complex fraction. Let's see what happens. Okay, so for my numerator, the sine x and this sine x cancel, giving me cosine x times the resulting sine y. And then this sine y cancels with that sine y, giving me cosine of y times sine x. There's my numerator. For my denominator, 1 times sine x sine y is, of course, sine x sine y. And then plus, these cancel entirely with these, leaving me with cosine x, cosine y. So, are these identical? Pretty much, yeah. All I have to do is rewrite this now as, let's move this over here, cosine x sine y gets moved over here, and cosine y sine x is this term moved over here and flipped around. That's good. The denominator, we just need to switch the order here, and we have sine x sine y plus cosine x cosine y. Ta-da! We are now finished. So that's the lecture for lecture 12, 5.3, and 5.4. Hopefully you go and have more fun than frustration. If you have any questions about anything, feel free to email me, and otherwise I will see you in the next lecture.